Good afternoon. And thanks, Annalisa, for introducing. It's a pleasure to be on this amazing conference. As a local resident, it's amazing to see how many people come to Vienna to speak technology and ultimately business. What are we going to do today? Hilary and I are speaking about Metaverse at work, working Metaverse, what's real today and what 6G will bring us. I'll speak a little bit about Metaverse at work, and Hilary will then come on stage and speak about 6G. So what did we do? I would call it, we did a reality check. With any technology that's new or that's in the market, which is buzzwords and trends, it's good from time to time to do a reality check to see if it's still a buzzword or if it really touches the ground and really gets implemented. So what Nokia and UI jointly did a global survey on the Metaverse to understand how much of it really kind of is working. So what we did was basically we looked at major markets. We looked at the US, UK, Japan, Germany, surveyed over 800 business leaders, and that was not only the tech guys. We really surveyed the business leaders that would ultimately get the value out of the Metaverse. And we looked at 4 key industries. We looked at automotive and automotive suppliers, industrial manufacturing, the supply chain and transportation part, and we also looked at energy at utility. On top of that, we surveyed over 20 key leaders to get a better understanding, to reflect some of the conclusions that we were drawing based on the results that we got. And to be very precise, we focused on the industrial and on the enterprise Metaverse, not so much, or excluded the consumer Metaverse. The cool thing is really 98% of respondents of the survey said it's not a buzz, it's not a fad, it's there. And that's quite a large number if you look at past technology trends, and if you at a certain point in time really looked at if they were real or if they were really touch basing the ground. Some of them kind of seeing it as a natural evolution of the gaming industry, of the social networks, but even more, some of them more kind of a natural evolution of the digital journeys, transformations they were taking. But over 50% or over 40% were saying, no, it's all encompassing, it's really adding value. It's going beyond a natural evolution of it. And that's quite a number. But even more impressive is that almost 60% of the respondents were saying they already had implemented, deployed one or more use cases, meaning they really already were taking value out of the Metaverse, and 40% said they were planning to do so within the next 2 years. So if we add up the numbers, there would be 98% of companies deploying use cases in the Metaverse. And that's quite a substantial number, again, if you look at some of the technology trends. And why is that, and what's the consequence out of that? If you looked some 5 to 10 years ago, and some of the digital technologies, there was a lot of playing around, there was a lot of POCs, there was understanding technology, there was testing technology, building up skills. That was the first 5 years, I would say. The last 5 years, what we see is much more focus on the business value that those kind of technologies create, and being very selective in where to put the money and to get value out of it. What's interesting with the Metaverse is here that if you look across the different items, that the level of realized benefits by deploying use cases is far beyond the expected value. And that's very interesting, because if you looked at some of the digital initiatives that we saw in the past, the level of expectation was much higher than actually what has been realized. And what do we see? We see there is a lot of positive impact on CapEx investments. Why is that? Of course, investing in physical assets is much more cost-intensive in projects than investing in digital assets. Sustainability, one of the key drivers, to invest into Metaverse, into digital assets, definitely even surpassed the expectations. Safety improvement. If you look at some of the use cases, maintenance work, maintenance in difficult, dangerous environments also surpassed expectations. Of course, customer experience is something that anyway is on top of, as well as OPEX reduction, cost savings, and some of the use cases that we see, like supply chain optimization, distribution network optimization, virtual grid optimization, the energy and utility sector give a lot of cost back. And quite important, time to market, bringing products quicker to the market also goes beyond. That together gives us quite a positive feeling about more use cases, seeing more deployment of Metaverse seeing in the market, because it obviously adds more value than is even expected in the market. We also asked companies, what do you see as the technology enabler? And at foremost, it's of course it's cloud computing. It's cloud computing because of the processing part, because of the energy. Excuse me? Here. Okay, sorry. Logistics. Okay. You can see me. That's hard. I thought I could walk around. I can't see the screen anymore. But there's also a technology gap. What does it mean? We see on the one hand, we see the technology enablers, but on the other hand, there's some difficulty in really deploying those kind of technologies. On the one hand, it's about the maturity of the products, the technology itself, but even more, it's about the maturity of the companies being able to deploy those technologies. At the foremost, the biggest gap, cloud computing, AI, and some of that is really legacy. It's about getting the basis right to really work on those kind of more sophisticated things. And we also see quite a technology gap in connectivity that Hilary will speak about afterwards. We looked at we asked what are the use cases? So if we know that over approximately 60% already implemented use cases, so the question is, which kind of use cases would we see in the market? And there's 3 interesting points. The first point is, while we do see some similarities of use cases being deployed in the various industries, and one of them being virtual R&D, and that's the biggest use case across all industries. Or we see it in the enterprise market, the training and the onboarding and some preventive maintenance. It's an industry-specific game. What does it mean? Each and every industry really has different use cases deployed, and we as a service provider or technology providers and companies themselves need to understand the value chain, the cost basis, where it's value being created, to really understand where to best deploy Metaverse, where to best deploy use cases. That's the one thing. The other thing, conclusion that we drew, because we asked, what are the use cases that you have already implemented, and what are the use cases where you see most transformative power and most value in the future? And here we see that there's a difference between what is currently being implemented and what will be really the game changers in those industries. So there will be more and more different use cases coming up. If you look at the different industry, for example, in the automotive industry, currently what we do see is virtual supply chain operations, optimizing the logistics, the supply chain is the currently being implemented use case. The virtual research and development, actually the development of the car will be the game changer. Whereas in the industrial goods industry, we do already see virtual R&D as being the most deployed use case, but the biggest case that they would see is the predictive maintenance, visualized predictive maintenance cases. Whereas, and that's funny, in the transportation supply chain industry, the predictive maintenance, and even in Austria, we already see some really good cases, like in the railways industries, where we do a lot of predictive maintenance. There's like autonomous RC delivery robotics or XR UX research. So in a nutshell, what we do see today is there's kind of the low-hanging fruits being deployed, but we know that there's a lot of value coming out of it, so good experiences in the market, and we will see companies working on those kind of game-changing use cases in the future. That's all the result of a quite comprehensive study that we jointly did with Nokia. We have the main paper, the executive report, but as I said, it is an industry-specific game, so we have derived some industry-specific for the four core industries, where you can read up the state of the reality check in the diverse industries and where it's going to. Let me introduce to Hilary, who will now speak about 6G and what it will change.
Thanks, Michael. Thank you. How is everybody today? Good. Good. So, so thanks for that. I want to talk about connectivity. And the reason I do is you will have noticed on, in fact, I'm just going to take you, by the way, if you can take a snapshot of that QR code for the report to make your life a little easier. And I do encourage you to read it. It's really quite interesting, and it's got some details on each specific industry. So I'll give you a minute because I can see some of you snapping away. Okay. You'll notice on these gaps, right? You'll see private 5G and 6G. Oh, sorry. Sorry about that. Private 5G and 6G being a gap, public 5G and 6G being a gap, fiber being a gap, and so forth. So is anyone old enough, and I doubt many of you are, to remember 40 years ago when the chief scientist at Sun Microsystems, okay, so first of all, does anyone remember Sun Microsystems? All right, my people. Okay, John Gage was chief science officer there, and he coined the term, the network is the computer. Anyone remember that? Anyone feel like the network is becoming the computer at last? Long last. So that's what I've been doing for the past 40 years of my life is helping the network become the computer, because I was in Silicon Valley at the time and thought that was very cool, so I fell in love with fiber optics. But anyway, I want to talk about the network today because, again, it's a really important part of helping this ecosystem become more powerful. So, and that was actually one of the key takeaways, right? So one of the key takeaways that one of the big challenges that people have is the network. Do any of you feel like the network is completely sufficient for everything you want to do? It's getting there. It's better than it was. It's a lot better than it was. So we're working on 6G, and I'm not going to talk about fiber today, even though it's the love of my life. I'm going to talk about 6G. And the reason I want to talk about that is 6G is something that actually I'd like to invite all of you, if you aren't, is anyone participating in 6G standards design or definition? Any of you interested at all? Okay, so the reason it's important, it takes us about 10 years from the time we start working on a standard to the time it commercializes. So 6G is planned to be commercialized in 2030, and you're going to sit there and say, why are you wasting my time? Because we actually have to build that ecosystem over the next, well, we started 2 years ago, over the next, several years. South Korea, as always, will deploy first, and they'll deploy in 2028. They've made that very clear, even though the operators there are giving spectrum back because they can't monetize it yet. But they're shooting for 2028. China has said 2030, but mass in 2030. They'll do in 2030 what they did with 5G, which is roll it everywhere. India is planning to be first in 6G. The US is going to be first, right, everyone's going to be first in 6G. But it will be, it is a ways out. But it takes us a long time because we need to get everybody on board in the connectivity world. You need to get spectrum aligned. You need to get ecosystem aligned around standards that work everywhere. So it's much more challenging and it takes a lot more time. So that's why we're working on it now. And what do we do when we bring each new standard? So 2G, these are 3GPP standards is what they're called, but they also get more complicated with other groups like IEEE, ITU, et cetera. There's a lot of groups that have to work together on the standardization to really make it work because it's not just about a radio or a core, it's really about systems. Every time we introduce a new generation, we target these sort of 10x improvements in certain things. So we look to really improve it in the existing generation. But then we also look to introduce new things. So what I'm going to talk about today, quickly, is just a little bit about what we plan to improve in 6G and what could be new, what that could mean for use cases. But I really want to invite you. I'm just here because it's so much fun to feel like a kid in a candy shop out with all the stuff on the show floor, right? So we need all that imagination to help us think about the use cases for 6G. So that's why I really invite you, if you're not part of working on any of this yet, get engaged with other colleagues and start giving your input, what the XR industry needs and what Metaverse ecosystem needs from 6G to be successful, right? That's really important to help us define. So clearly the first thing we're going to do, we always optimize around bandwidth because spectrum, of course, is finite. There's no extra spectrum lying around. There's only so much spectrum, so we always have to use it more and more effectively. So just like with fiber, we're always driving more terabits through fiber. Same thing with spectrum. We're always optimizing radio. airwaves and driving more through them. So if you think about 4G was targeting 1 gig, 5G, we've shown 10 gig now on 5G, we're targeting 100 gig as sort of peak load on 6G. So it's, again, massively more effective use of the same spectrum. We want to do that, of course, in a way that uses less power. So we have a huge power consumption challenges to constantly work when we're working on the 6G standards. And we're doing some interesting things. Managing power is not just about the power consumption of individual components and at the chip level, but it's also about systems and devices. So one of the things that will be new in 6G is we're thinking about zero power devices. So I'll talk about that in just a sec. I also know I talk too fast, I'm sorry. So if I'm talking way too quickly, someone can raise their hand and scream, okay? Because I apologize. English is my native language. It's just not fair. And I don't know. I grew up on the West Coast, but somehow I spent some years on the East Coast, and it got into my blood. So we're going to use, in this generation, we're going to use all the latest tech that we can, right? So we'll use AI ML. We use it today already in our chips, but we'll use it in more various places. Again, around that optimization of spectrum, optimization of power. Then we need to think about things like security. We'll also use quantum. We'll also use, we do a lot with silicon today. We'll continue to do a lot with silicon. And by we, I mean the industry as a whole, right? Just very quickly, so we think traffic grows around 30% every year. Anyone track traffic growth ever? No? It's an esoteric thing to do, but it's interesting to me because if you don't understand patterns of traffic, you can't really build the right networks. But traffic has continued to grow, and we expect it to grow. So Bell Labs, Nokia Bell Labs does a bunch of analysis of this and of traffic requirements because we have to think about what the world looks like in 2030 if we're going to define the standards now for that world. We're also thinking about latency. Does anyone care about latency? Yes, thank you. Latency is incredibly important, and it's incredibly important for this world of XR. So we target sub-millisecond, right? We've been targeting under 10 milliseconds with 5G, and the target with 6G is under millisecond. Now, that won't be true for everywhere, but that'll be for specific use cases. And that becomes a really important part of the spec as well. And I'm going to actually skip here and then go back to the last slide. So what do we want 6G to do for us? So if we think about, I'm not going to go through all of these. This is so you can take pictures of it and think about it. But I said before that we do some enhancements. So a really obvious set of enhancements is with increased capacity, with lower latency, et cetera, you can really do things in terms of telepresence. And I saw some incredible stuff on the floor in terms of the degree to which we're able to, rather than a really crappy avatar from a couple of years ago, right? We've got some pretty sexy things going on out there. Now you'd like to be able to move those around across space and time with a network, but they are hugely bandwidth consuming. So we need to continue to work both to reduce the bandwidth required to do really natural avatars and at the same time continue to improve the network to handle it. Does that make sense? So that's the kind of thing that's of an enhancement. On the new services, though, one of the things that I get pretty excited about is digital twin of everything. So interactive mapping and interactive real-time digital twinning. And I think that my brain is too old and stupid to think of all the cool use cases, but I think you guys and more people in this ecosystem will think of amazing things to do as we do that. So you can start thinking about smart cities that are much safer. I have this idea of the city planner having a completely new job, right? It's a completely new way of thinking about how you plan for urban living. Drone swarm management. We do drone swarm management today in ports, for example, which need drone swarms to do security surveillance or other kinds of things. Drone swarm management is an example of something where you really need very good bandwidth, low latency, and so forth. Improved health outcomes. So when you think about this real-time digital twinning that you could do, think about cobot safety. There's a bunch of different use cases. Digital healthcare. The other thing that's super interesting is thinking about low-power devices, zero power, we call them. So You can imagine wearables and also terahertz networking, right? So you can imagine wearables and also in-body network equipment, devices that communicate with each other for better healthcare outcomes. Anyone have older parents? Or a friend who has diabetes? Or, yeah, exactly. There's a bunch of different use cases, and of course we have a challenge as a worldwide of a baby boomer population who are all a drain on our financial resources and on GDP. So everything we can do to improve health outcomes and reduce that cost is good. And also to make people's lives better, right? Because if you can manage the later stages of life or through a disease better, that's a good thing. So a lot of things you can do if you can start to do real-time digital twinning. Last thing I wanted to mention, and actually I'll talk about zero energy devices. So the idea behind zero energy devices, think about a tag on a shipping crate which has no energy of its own, but it collects energy when it needs it from either vibrations, from light, from the radio network itself, right? So there's multiple ways that we're looking at how we can create what we call zero energy devices, which could be a very cool way to be able to tag information. Eventually, you'd like to do that with embodied devices. I know a woman who's working on research where you can do various kinds of cardiological tracking with zero energy in your body, right? Using your own heartbeat, for example. So there's a lot of interesting things we can do there with zero power devices. And that's, again, some of the cool new stuff that 6G will bring. How am I on time? Okay? So back to what does that mean? Ta-da. So this is just a subset of requirements. I was thinking about this, and I'm trying this out on you. I've never used this before. I've never given this talk, actually, so bear with me. And thank you for being my guinea pigs. I'm thinking about the idea of what I'm going to call the 6 Ps of network connectivity that we need to think about when we think about 6G and when we think about the rest. First is pervasive. The network really needs to be pervasive. It's wherever you need it, whenever you need it, however you need it, right? The right SLAs. Second, it needs to be predictable. And for those of you who are geeky about connectivity, you know that actually for a lot of XR applications, it's the predictability of your connectivity is even more important than the bandwidth, for example. You need to know that it's going to be exactly that. You're going to get exactly the performance you expect in a consistent way for a period of time. So predictability is very important. Performance, obviously, we want more than ever to have lots and lots of bandwidth and very low latency. Power, everything we can do to reduce power consumption and also improve circularity is really key. Power is, has to be managed, full stop. And then privacy, and I'm using privacy as a P for privacy and security. So security, every time we create additional technology, we increase the number of threat surfaces, right? We increase the number of threat vectors. So we're constantly working, like we've been working already in our fiber group. We have now quantum safe optical networking, right? We're working always on how we prevent the next round of technologies from making even bigger nightmares. We won't be able to prevent it completely, but we can do our best, right? And then price. Price is cost, right? Cost has got to be in the right place, otherwise you can't be pervasive, you can't get the performance, and so on. So the 6 Ps, pervasive, predictable, performance, power, privacy, and price. You like that? Good, thank you. I like that. I was like, I like that better than that. These are our, but anyway, but it's the same basic idea, right? So you can take a picture of this, and if you want a picture of kind of the basics. There's also a really good, Nokia Bell Labs has written a whole book on 6G and the requirements. It's actually 2 years old, it's still really good. So you can go to just Google or Bing or whatever your favorite. I have read, by the way, did you know Gen Z's favorite search engine is YouTube? Did anyone know that? Yeah. It's YouTube, actually. TikTok's number 3, I think, for the Gen Zs. Anyway, but use whatever your favorite search engine is, Nokia Bell Labs 6G, you can find all kinds of cool stuff if you're interested. So last thing I just wanted to mention is the other cool thing. So zero power devices, and the other cool thing we're working on in 6G, and we did a demo at Mobile World Congress this year using 5G, but of course it's not cost-effective and or scalable at 5G, you have to have 6G, is the network as a sensor. So you'll hear, for all my geeks out there, if there's any fellow geeks, and I think there are, you'll hear the term JCAS or ISAC. So ISAC is Integrated Sensing and Communication. JCAS is Joint Communication and Sensing. It's just, depending on what part of the world you're from, it's the same thing, but it's about using the network as a sensor. You use some devices, but you're basically shooting, think of the network as a radar, bouncing signals off of objects and being able to tell where those objects are, whether they're moving, and potentially what they're made of. So those are the things we're working on now. We've already shown and demonstrated that we can use the network all by itself with no devices to tell what something is and whether it's moving. Now we're working on what is it made of. So what does that mean? You can do things like use just the network to tell whether your mom's fallen down and her heart is still beating. You can use the network when there's fog somewhere, yeah, to see, good, I'm almost done. To see whether there's a car coming around the corner that you couldn't see. You can use the network when it's foggy and it doesn't work well for video to capture other information. So to me, that's a super sexy one. I'm going to leave it with you to figure out all the cool things we could do with that. Deal? Okay. And I'm going to leave it there and turn it over to any questions you have.
Fortunately, we don't have much time for Q&A. Just a very quick question.
Sorry. I get enthusiastic.
Yeah.
I warned you.
Yes, it's interesting networks.
Hi. So you talked about citywide digital twins and network as a computer. So I am actually working on citywide digital twins, real time, about 100 square kilometers, and we are pixel streaming this through Unreal Engine. And this is up until now a desktop application. What I'm wondering is with 6G, yeah, from your slide, it makes sense that I'll be able to do that. But will I be able to bring virtual reality, like full virtual reality, high resolution digital twins run on the network through such pixel streaming or similar
It's going to be some combination, I think, right? So I think what you're going to end up doing is you'll do some bandwidth, you'll do some tricks. Sorry, you'll probably do some algorithms and bandwidth tricks to make it require less bandwidth to get the same effect, right? So we do things all the time where you can get the same effect but not using everything. And at the same time, you'll have the bandwidth. So I don't know the exact bandwidth specs of what you're talking about, but we could take that offline and talk about it.
Thank you so much. Thank you.